This begins the section on evaluating worker exposure. Before I get into the PowerPoint, I wanted to spend just a couple of minutes showing you some links that I have up on Blackboard under weekly course information and the exposure evaluation. There's a reading assignment which is from an old edition of the White Book, AIHA, where Cheryl Miltz from the University of Toledo wrote, I think, a very good chapter on the type of things that you need to do if you're going to go out and do any sampling to evaluate exposure. Sort of things to think about, and I think it's a very excellent chapter. The other things are, if you ever are asked to do some air sampling and you haven't had an opportunity to use some of the instrumentation, or the instrumentation that we have is not the same that you will have at the internship or job, there's some really good resources that are available to you. Many companies have training videos on how to use any sampling equipment that you may rent or purchase from them. I have a link here to Galston Labs. There are other companies that do this, but this is one that you can look at and get an idea for all of the different types of instructions that are available for many different types of sampling that you may be asked to do. And it goes through a step-by-step analysis of what equipment you need, how to use the equipment, what you'll need to be doing, how the lab can support you, etc. So that's a really good source of information. SKC is another group that has some really good information as well. And here I have some of their instructional information on step-by-step air sampling procedures. So depending upon what you're going to be doing, there are some really good resources out there available to you. And the other thing that I wanted to point out is the Exposure Assessment Committee from AIHA. It has a membership list on this website, and you can find some people who are very knowledgeable in exposure assessment, different type of sampling. And also this link here on tools and links for exposure assessment strategies. What they have available are some software that they've developed that can do calculations, ventilation calculations, and things like that can be extremely useful if you are going through a calculation on what could be the worst case scenario. How much, if all this chemical got released at once, what would be the concentration in the room? These downloads that they have available can do those calculations for you, and they're free downloads. So I think that's useful to let you know about those a little bit before we start. Anyway, back to what I wanted to talk about in the lecture. This is the principles of evaluating worker exposure. And to do this, I want to approach it from the definition of industrial hygiene. What are the elements of industrial hygiene? Anticipation, recognition, evaluation, and control. And all of these are going to be used in evaluating worker exposure. First of all, if exposure may occur, hopefully you can anticipate it. And if you have an opportunity to participate in the planning of any new construction, any process change, you may be able to anticipate a problem that can occur and remove it before it becomes an issue later on where it's more expensive. Recognition, getting to know everything that's going on in the facility, familiarizing yourself with the processes, knowing the inventory of agents that are there, review any jobs that are occurring, know any existing control measures that are out there, can all help you assess what exposures may potentially occur. And then evaluation, and this is what we're going to be spending our time on next week when we talk about specifically how to evaluate for gases and vapors and aerosols. We're measuring things. And measurement really is to determine the magnitude and significance of health hazards, because you're trying to determine how much is there, and is that amount significant compared to any type of regulatory standard or recommendation. And then the last is control. And to control a hazard, you again use a hierarchical approach where the first thing you'll try to do is engineering controls. If you cannot implement sufficient engineering controls, try work practices or administrative controls. And the last thing you ever want to do to control a hazard is to use personal protective equipment. Now that's sort of a general overview. Now, what if you're asked to go do some sampling somewhere? You have a facility and they have some kind of a problem and they want you to go do some air sampling. What you need to do is go through a process of gathering information first before you begin your sampling. And this evaluation process is going to consist of a lot of different steps. You want to, again, try to familiarize yourself with any type of a process that may be occurring. You want to know what raw materials are present, what byproducts, what intermediates, what products are coming out the end, because all of these could represent a potential hazard or exposure to the workers. The methyl isocyanate release in Bhopal, India, was from an intermediate. It was a pesticide production plant from Union Carbide, where the intermediate was methyl isocyanate, and that was released and resulted in thousands of deaths in India from the intermediate. So it's not just the raw materials and products you need to be concerned about, but things that happen in between. The intermediates can be very hazardous as well. Know any auxiliary operations that are occurring. If there's anything that's going on that is a little bit out of the ordinary, information from material safety data sheets can help you with everything that's present, any factors that may influence the hazard, what work methods are going on, any unusual conditions, etc. So you want to kind of go through a little bit of an evaluation process before you start, so you can kind of hone in a little bit better on what it is you're going to be working on. And then I recommend that you do an exposure assessment survey. And one of the first things that's important to do is to walk around the facility and take advantage of your sensory input, because certain chemicals have characteristic odors, and that can help direct where you're going to be sampling. If it's an aerosol you're sampling for, you can look around and see if there's any dust in certain areas and not in others, and that could perhaps help you direct your air sampling strategy a little bit more effectively. These aren't necessarily going to be the answers to how you need to do things, but it can give you some input that may prove very valuable. The next thing you want to do is look at, see if anyone else has done any previous monitoring at all, and if so, what did they find? So look for any records that have been done before on monitoring, because that can help you in your air sampling as well. Then the third thing on this list, and I think this is really important, and that IH-MOD download that I showed you from the AIHA Exposure Assessment Committee can be really, really useful, is do a calculation. If you're concerned about, okay, what chemicals do we have present that may be close to a PEL or a TLV, you can do that by calculation, because you can use some of those formulas to determine, okay, if all of this chemical was released at once in this room, what would be the maximum concentration that could be achieved? And knowing some of the properties, like the vapor pressure of the chemical, how volatile it can be, the quantities that are going to be used, what ventilation is present, you can sit at your desk and come up with a pretty good estimate on what would be the worst case scenario, or the maximum levels of chemicals that could potentially be there. And if they're well below a permissible exposure limit or a recommendation, they may not be a chemical that you necessarily need to focus a lot of attention on. Or if there is a potential that they could get to a very high concentration reasonably quickly, you may want to focus a lot of attention on those chemicals. But don't overlook a calculation, because it can really help you direct your resources most effectively. Then the last on this list is just talk to people. There's been people that have probably worked on those facilities much longer than you have, and just go ask them questions. See if there's any symptoms or any smells or anywhere that they think chemical concentrations may be higher. Look at medical records if they're available, and you can get some basic information on areas that may require additional attention. Then to go about your air sampling, you want to use a strategy. And it's kind of like being a detective. You want to do the who, what, when, where, how long, how many, and how. And you do this as a strategy because air sampling is expensive. You cannot sample everybody for everything. So you really have to target your resources very effectively to do this properly. So you need to sort of ask questions on who you want to sample, what you want to sample, when you want to sample, where you want to do the sampling, and how long and how many samples you need to take. And let's go through some of those things. Who do you want to sample? Well, the answer is that depends. If you want to know what the average exposure is going to be in a facility representative for health effects, you might want to pick random people at different parts of a facility to get an idea of what most people are going to be exposed to. If, alternatively, you're concerned about the worst case scenario, who's going to be at the highest concentration at all of anybody in the facility, because you may be worried about a compliance issue, you might want to target the person who is closest to an operation where the chemical levels are the highest. And then you may have some environmental issues where you don't want anything on the facility to go through the fence line, so you may be sampling remotely or nearby a facility or something like that. So a who question, again, it depends on what you're getting the information for. Now what? Sometimes it's easy. There's a single chemical there and you want to sample for that chemical, but that's unlikely to be the case most of the time. Usually you have a mixture of chemicals, and if you have a mixture of chemicals, or in some cases dozens or hundreds of chemicals, which ones do you really want to put your resources on trying to measure? And some things to consider are which chemicals are the most toxic, and they may deserve most of your attention, or which ones are most likely to be inhaled, and these would be those that are most volatile. And so those are some things that you might want to consider before you do your sampling strategy. When? Do you want to just do one shift? Do you want to sample for longer than a shift? Are you more concerned about summertime conditions because of volatility or winter? So there's some questions there on when to sample. Where? You may sample at a specific operation. You may want to get a representative sample in a general workroom so you could sample in different parts of the facility. Or you may be really concerned about what the worker himself is exposed to, and so you would do a personal breathing zone sample where you would attach some type of an air collection device on their lapel, and you could then determine the concentration of contaminant in the air that they would actually be breathing. How long? This is where you really need to develop a good relationship with an analytical laboratory, because they can tell you how much sample you need to collect in order for them to be able to analyze it. And so this could be very helpful in determining if you need to collect samples for 8 hours or 48 hours, because sometimes if you don't collect a sufficient amount, the laboratory can't analyze it. And if you really if you're really sampling very low concentrations, air concentrations of contaminant, you have to collect enough on the filter that the laboratory can tell you if the chemical is going to be present. So finding out how much you need to collect will help determine how long you need to sample. Or alternatively, you could be just worried about a toxicology-based type sampling, and so you would be interested only in what worker exposure is. So you have some choices that you can make on how long to sample. And how many? Well, again, that depends. It depends on what you're doing it for. If you're doing it for to try to find out if there are areas that you need to do more extensive air sampling, going through and doing some Draeger tube analysis that could give you a qualitative yes or no answer pretty quickly, may be sufficient. Alternatively, if it's a compliance issue with OSHA, you need to collect a statistically significant number of samples, you may need to do a different type of sampling strategy. So how many, again, it depends on the purpose of what you're doing the sampling for. And how? Well, next week we're going to talk about some of the hows with instrumentation. And if you had a wish list of instrumentation, you want to get things that are going to be portable, easy to use, efficient, reliable for the conditions and the type of analysis desired. And if you go to the AIHA conference and exhibition annual meeting, you'll see all kinds of instrumentation that's available and could be pretty handy and useful for industrial hygiene analysis of many, many types. But sometimes the reality is just what you happen to have there because you don't have an unlimited budget, and you may be using the instrumentation that has been purchased before you arrived at your job or your internship. But there are a lot of things to consider if you do need to travel over a fairly large distance with weather conditions that may be variable. You might want to get equipment that you could drop and get wet and not have to worry about recalibrating it every time or breaking it. So there are a lot of different things that you may want to consider when buying instrumentation for what it's going to be used for and how it's going to be used. That would be very, very helpful. And we'll talk about some of the choices that you'll have for different types of sampling of gases, vapors, and aerosols next week. And whenever you do exposure analysis, especially air sampling, you have to remember that not all chemicals get inside of the body just by air. There are other routes of exposure as well, and these could include skin absorption, ingestion, or off-the-job exposures. Now the next part is just a little bit different. I want to give you an overview of some sampling that I did one time at a facility just to give you an idea of how this sampling stuff actually works and some of the choices that you make in sampling. This was a litigation case where a former pesticide and herbicide formulator and applicator was trying to sell a building which contained 4,000 square foot of space, including some office space and some areas where chemicals used to be stored and handled. Before the sale, there was some previous sampling that was done, wipe samples, where a wipe sample is essentially where you will wipe a Kleenex on called a chem wipe on a surface area, and they detected some chlordane and DDT, some older banned pesticides, and some grab samples, which were air samples, detected these as well. Now, a little information about these chemicals. They do have LD50s and oral. Both oral and dermal. There are principal exposure limits that were established, and immediately dangerous to life and health levels were established as well for the chemicals that were detected. But this was again a litigation case, and so the two parties that were involved had an opportunity to negotiate amongst themselves about what they wanted to make sure to do about concentrations of these chemicals not being a problem. So the legal issues were that the previous occupant will, at its sole expense, perform the following work: remove all interior construction materials, ensure no harmful chemicals of health and safety significance were there, coat the interior with a sealant, conduct sampling, both air and wipe, to confirm acceptable levels. And both parties agreed upon using this document from the National Academy of Sciences in 1992 called An Assessment of the Health Risks of 7 Pesticides Used for Termite Control. And chlordane, DDT, as well as some other chemicals used to be used for termite control. And this is kind of an interesting document in that it was written using information from military bases, that some of these termiticide insecticides used to be used in the barracks, and they had very good data on the levels that were used and the exposure to many of the soldiers for a number of years, and so they had some really good information on what the health risks of these pesticides actually were. Now, these things have been banned because of their persistence, but that was the reason they used to be used back in the 70s and 60s when they were available, because you could put them in a crawl space or underneath a facility and not have to worry about them for the next 30 years because they would stay there. So they were very persistent pesticides, and that was part of the issue with this particular litigation. Anyway, the other legal issues was once this work was completed and these levels were confirmed as acceptable based upon the National Academy of Sciences document, to issue a certificate of habitability, and then a second expert, which was my role, would issue an opinion that the indoor air and surface contamination is of no safety and health significance. Now, how do we go about sampling on this? Well, NIOSH has approved methods for sampling, both to collect air samples and to analyze samples in the laboratory. And there are links available to go to NIOSH approved methods, and they're very good if you're going to be doing any type of sampling. We used SKC, which is a typical industrial hygiene vendor, for their air sampling pumps. We used OSHA versatile samplers, which are OVS tubes, and we collected 8-hour air samples and 100 square centimeter wipe samples. And to collect the wipe samples, again, you use like a Kleenex. It's called a chem wipe, and you have a little template that's a 10-to-10 cardboard cutout, and you put it on a surface, and you wipe that surface with the chem wipe, and then you have that sent to the laboratory later to be analyzed. Now, the detection method was also a NIOSH method, NIOSH 5600, which is an analysis for organochlorine pesticides by gas chromatography and electron capture detector. And what this method consists of is we would cap and send the OSHA versatile sampler tubes to a contract laboratory. We used Datachem in Salt Lake City in this case. They were desorbed with a solvent which consisted of toluene acetone, and aliquots were injected into a gas column on the gas chromatography, and were analyzed using electron capture detection. Just to give you an idea of the expense for organochlorine insecticide analysis, it cost at that time $210 per sample. We sent in 7 samples. Every time you send in a sample, you have to send in a blank, so you want to make sure that anything you're doing in the process does not contaminate your samples, so you have to pay for your blank analysis as well. So just a few samples, 7 cost $1,470. So you can see the costs for certain types of air sampling can get rather high rather quickly. So it's very important to be effective in targeting your air sampling strategy due to cost limitations. So what did we find? We found detectable levels in the air of chlordane, heptachlor, none of DDT or none of dieldrin. And fortunately, our blank was non-detectable, so we didn't have any contamination issues. Now, the good thing about those air levels is that the maximum levels that we detected, and in the case of chlordane, 12 micrograms per cubic meter, in the case of heptachlor, 0.43 micrograms per cubic meter, were well below the National Academy of Sciences guidelines that, again, both parties agreed to, of 5 micrograms per cubic meter. The 0.12 is much less, and the 0.43 is much less than the 2 micrograms per cubic meter. So we were okay in the air levels in terms of saying that they were not a health and safety significance. The next thing was the surface samples, and so we did a couple of wiped samples. One was in the general area of the floor, another one was close to a drain that was in the middle of the floor. And near the drain, which was wiped too, we found levels of every pesticide that we analyzed for: chlordane, heptachlor, dieldrin, DDT, and we found one of heptachlor in one of the wiped samples. And again, our blanks had no detectable levels, so we did our sample collection properly with no contamination. But the question with here is, what do these numbers mean? If you go to look at PELs or you go to look at TLVs, you don't see anything for a surface sample. So if you find 0.21 micrograms per square centimeter, how does that apply to any type of a regulation or recommendation that you have for an occupational exposure limit? And the answer is it doesn't. So you have to do some thinking about how to apply that to the situation for health and safety significance. And the approach that I used was to say, okay, the National Academy of Sciences guidelines for chlordane, for example, say that you can be exposed to 5 micrograms per cubic meter. Now, how does that correspond to a dose? In other words, how much of that can get into an exposed individual's body? And if you have an air level of 5 micrograms per cubic meter, and a person breathes in 20 cubic meters of air a day, 5 times 20 would correspond to 100 micrograms of chlordane that could get inside of your body, and you would still be okay with the acceptable daily intake based upon the National Academy of Sciences guidelines. And I did similar calculations for each of the chemicals and came up with 100 micrograms for chlordane, 40 for heptachlor, 20 for dieldrin, and 35 for DDT. And the corresponding, trying to apply that number of how many micrograms could get inside of your body from the NAS guidelines to how much of that material we detected in the floor, would be trying to determine how much of that, how many square centimeters of surface area of the floor would you need to absorb to approach the levels that are allowed to be exposed to by air. And I know this is a little bit odd of an approach, but the way to think of this is that for chlordane, for example, you would have to absorb all the material from 4,761 square meters of floor in order to approach the 100 micrograms that you would be considered acceptable to get inside of your body from breathing in 5 micrograms per cubic meter in air. And correspondingly, dieldrin 9,091 and DDT 25,000 square centimeters. And the way to think of this is that you would need to be barefoot or licking the floor or something like that to get that much chemical inside of your body. Is this likely to happen? Well, again, it depends. It depends on what the facility is going to be used for. If you're going to be using it for an office space and you're putting a carpet or tile down, the odds of any type of exposure are very close to zero. If, on the other hand, you're going to be using it for a daycare center where kids will be crawling around on the floor, this may not be the best place to have that, because there are measurable levels of contaminant in the floor. But under normal situations where you would probably be putting down another coat of sealant, a tile, possibly carpet, and people would be coming in with shoes and socks on, they're unlikely to have exposure from any detectable material that would remain behind on the floor. So what our conclusions were is that no levels of chlorinated pesticides were detected in the indoor air. that exceeded acceptable levels set forth in an assessment of health risks of 7 pesticides used for termite control established by the National Academy of Sciences, and the levels of chlorinated pesticides detected in surface samples are of no health and safety significance. So this is kind of an introductory lecture on exposure assessment with some guidelines on how to do it and an application of an example of something that I actually did at one point. And next week we'll start looking at specific instrumentation for gases and vapors and specific instrumentation that are used in the sampling of aerosols. And I would encourage you to keep those links to the vendors like Galston and SKC and the link to AIHA Exposure Assessment Committee, because I think it can be pretty valuable if you're ever doing any air sampling.